Hi everyone, we're back with another video about rational functions, and the topic of this video is going to be zeros and how do we find them in a rational function. So as we've seen throughout the course, there's a lot of tools that we have for finding zeros of all different types of functions. When we were talking about factoring, we talked about the zero product property, how that was super important. And what we're going to do here is we're going to add another property that allows us to find zeros of different functions. So I want to start out with a question. Suppose we have a rational function here, and it looks like this: 2x plus 1 divided by x squared plus 5. And I want to know, what are the zeros? Right? So what are the zeros? What are the zeros of this function? Now what we're going to do to think about this is we're going to introduce something that I call the zero quotient property. So the zero quotient property says this. Okay? If you have two numbers, say a and b, and you divide them like this, and you get an answer of 0, there's really only a couple things that can happen. So if you're not sure what has to happen here, what I would invite you to do is pause the video and just try plugging in different numbers for a and b and see what happens. Right? See if you can get this to be equal to 0 by plugging in different values for a and b, and then see what happens. Okay, so if you have a guess, then the answer to this question says, well, if a divided by b is equal to 0, then either a has to be 0, right? So there's no other way for me to get this to be 0, but also we know that b can't be 0. Okay, so if b was 0, we'd have a division by 0, and that would be a problem. Okay, so if I think about this, if I go back to my rational function, well, I have a fraction, and zeros mean I want to know when is my output equal to 0. So, well, I know that whatever a is, so a is the numerator, right? Whatever a is has to be 0. So in this case, 2x plus 1 has to be 0. And I have to make sure at the same time that my denominator is not 0. All right, so for a rational function, if I want to know when this is equal to 0, what I would say is, well, I need to know when is 2x plus 1 equal to 0. Okay, so let's do that. So this amounts to asking us, well, when does 2x plus 1 equal 0? And if we rearrange this, we get x has to be negative 1/2. Right, so you subtract 1 and then divide by 2. We get x is negative 1/2. All right, so if I plug negative 1/2 into this function, my numerator is equal to 0. But we also want to just double check really quickly. Is x squared plus 5, when I plug in negative 1/2, is this thing equal to 0? Okay, so if we get 0 over 0, some funky stuff could happen. So we want to just double check. Negative 1/2 squared, is this question mark equal to 0? And very quickly we see that, well, if I square something and add 5, it's going to be a positive number. And so, no, we don't have an issue there. So the zeros of our function are just the single one right here, x equals negative 1/2. So this is the only 0 to our function. And so the zero quotient property is a very powerful tool for us, and I'll run through a couple examples showing how to use it. All right, here we go. Here's another function. F of x is my function. It's a rational function, x squared plus 4x minus 21, all divided by x cubed minus 2x squared. And the question is, what are the zeros? What are the zeros of this function? So typically when I'm trying to find the zeros of a rational function, it's really going to be helpful for me to factor both of the polynomials. So if I can look at my numerator and my denominator in factored form, what that's going to do is allow me to identify the zeros of the numerator very quickly and then check them against the zeros in the denominator. So I won't always have to plug my values in to check if my denominator is 0, because if I factor it, then I'll know right away what the zeros are. Right, so let's go ahead and let's see if we can factor our numerator. So x squared plus 4x minus 21. Well, this is a quadratic. So this numerator right here is a quadratic. So if I'm factoring, I have a leading coefficient that's 1. So I ask myself, can I come up with two numbers that multiply to be negative 21 and add to be positive 4? If we pause and think for a second, well, things that multiply to be 21, 7, and 3 come to mind, and they differ by 4. So if I want it to be positive 4, I would get positive 7 and negative 3. Those multiply to be negative 21, and they add to be positive 4. So my numerator is going to factor like this: x plus 7, x minus 3. Okay, so we can check that if you'd like. And I think about my denominator. Also a polynomial, so if I look, there's no constant term, or the constant term is 0. So what that tells me is I can pull some x's out of here, and it looks like I can pull out x squared, which is very nice. So this is x squared, and then what's left over is an x minus 2. All right, so we factor our numerator and our denominator. Now, if this thing is going to be equal to 0, then, well, there's only one thing that has to happen. Well, I have to check, right? Check that numerator because of our zero quotient property, x plus 7, x minus 3. Since I factored it, well, I know what it's going to be. Okay, so this is our A, this is our B, and, well, A is 0 when x equals negative 7, and positive 3. Okay, well, check these against your denominator. If I were to plug in negative 7 and 3, well, I know it's not going to be 0 because, well, the only zeros of the denominator are 0 and 2. Right? So those don't match up. Okay, so the zeros of our function f are x equals negative 7 and x equals 3. Right, so this is just one example on how to find the zeros of a rational function. Right, so let's go look at one more. I'll be right back. Okay, so we're back here, and what we would like to do is figure out the answer to this question. What are the zeros of this rational function x times x minus 1 all divided by x squared plus x minus 2? All right, by the zero quotient property, I know that I'm just going to check my numerator. So I want to know, when is x times x minus 1 equal to 0? Okay, so when I think about this, well, I'm already factored, so this is all very nice. So I know x has to be 0 from this right here, or x has to be 1. X has to be 0 or x has to be 1. Okay. So a common mistake is for people to just stop right here and say, well, the zeros are x equals 0 and x equals 1, but this would be a mistake because we have to remember to check against the denominator, because if we are also going to divide by 0 in one of these cases, that would be bad. So I can see right away that if I plug 0 into my denominator, I'm not going to get 0 because I have a constant term here as negative 2. However, when I plug in 1, right, so if I plug in 1 up here, if I take this and I plug it in, right, I am going to get 0. And I am going to get 0. I'm going to get 1 plus 1 minus 2 is 0. Okay, so this tells me that something weird could happen because I have the form 0 over 0. So the way we deal with this is we will often take our function p of x and write it in reduced form. Right? So it's x times x minus 1. Then if I factor this denominator really quickly, can you think about it? Two numbers that multiply to be -2 and add to be +1. Looks like x plus 2, x minus 1. Right, so what I see here is I actually have a common factor of x minus 1. And so if you recall the previous example, we always said, well, it's really nice if you're already in factored form. And so what happens here is this -1 and this -1, right? So these x minus 1s, they can cancel out. And what I can do is write this as x over x plus 2. Okay, so p of x really is x divided by x plus 2, except for one spot, when x does not equal 1. Okay. So if you wanted to think about it this way, right, if you wanted to take p of x and reduce it down and look at it as x over x plus 2, you always have to add this caveat that x is not equal to 1. Right? Well, to finish this off, if we go back, our original question was what are the zeros? And the only zero of our function p of x is x equals 0. Right, so x equals 1 is not a 0, but it is an important point. So we did all this work and we got 1. So a very natural question is for us to ask, well, what happens when x equals 1? And it turns out that's where this part comes in, when you have a whole. Right, so a lot of the time when you have factors cancel out like this, one of the possibilities for a 0 over 0 form is that you have a whole in your function. Okay, so there are some other possibilities that we'll talk about in the next video. So I'll see you then.